EES, which is pronounced ease, is an acronym for Engineering Equation Solver. In this video, we'll learn how to access help in ease, and then also how to use the function information window to navigate through ease's built-in functions. Extensive online help is provided with the ease program installation. The index page is obtained by selecting Help Index from the Help menu, and then context-specific help can be obtained by selecting the F1 key at any time. So for example, if I hit F1 while I'm in the equations window, I'll go directly to the help page describing that topic. If I press 1 while I'm in the solutions window, I'll get that help page, and so on. Once you're in the help page, if you click on any word that's shown in blue font, you'll move directly to that subject. There's also a context tab and an index tab in the left pane of the help window, and clicking on any item in the contents tab is going to link you directly to the page for that item. The index page allows you to search for a specified keyword. So for example, I can search on the $keyboard directive in this pane, and I'll get right to that particular help page. Help information for built-in and library functions in ease can be accessed by selecting the function name in the equations window, and then right-clicking on it to bring up this pop-up menu, and you'll see that help for the selected function is one of the options. The ease help is included with ease in the file ease.chm, where the CHM extension stands for a compiled HTML file, and that's the preferred method for distributing online help for Windows programs. But it is true that some networks do not allow .chm files to be transferred from a server to a client computer for security concerns. And if you find that the online help is not working, it's probably because of that, and we'll recommend then that you contact your IT person, as this problem can be resolved as discussed in either of these two links. So these should solve that problem. If you still have problems, the ease help files are also located on the F-Chart website at this link right here, and that provides yet another alternate method of reaching the help information if the ease.chm file cannot be made available. The selection help index with web in parentheses also opens the web page online that contains the help information. Now, there are several other methods of obtaining helpful information within ease, and they can all be accessed from the help menu. The ease manual is a PDF file that is provided with ease and also available on the F-Chart website at the links shown here. The manual can be accessed with the ease manual command right here if the manual has been downloaded and placed in the same folder as the ease application. The Mastering Ease ebook is certainly the most comprehensive source of information about ease, and that book can be purchased from the F-Chart website. If you've done that, then you can also access that book from the help menu. Ease provides many built-in functions, and the built-in math functions provide basic mathematical, trigonometric, statistical, and other capabilities, as well as convenient commands to operate on data files and tables. The built-in math functions can be most conveniently accessed by selecting Function Information from the Options menu, and that will bring up this Function Information Dialog. By default, all of the built-in math and string functions are initially shown in the list on the left of the dialog. The list of functions can be reduced, though, by selecting a function classification from the list over here on the right. So, for example, here we can just look at functions that are related to Bessel functions, and you'll get that list over here on the left. The Function Information button provides the specific information about the selected function. An example of the proper use of the selected function is shown in the edit box at the bottom of the dialog. The text in this box can be edited by you in order to make the function call match the situation that you have in your ease code, and then the function will be pasted into the equation window at the current cursor position if you hit the paste button. So as an example, suppose we wanted to know the probability of an event that followed a normal probability distribution. So maybe we have a machining process that's producing shafts that have an average diameter D bar equals 0.500 inches, but there's a standard deviation around that average of 0.005 inches. And we would like to know the probability that the next shaft that's produced is going to lie between D min equals 0.490 inches and D max equals 0.505 inches. So between two standard deviations below the mean to one standard deviation above the mean. So the way to do this then is first enter the known information into ease, and as I do this you'll note that I'm including units in square brackets, and that's a subject that will be covered in the units section of this tutorial. I'm also adding comments to make sure that everybody is clear about what each variable represents. Once I've done that, I can hit the solve button, so F2, or solve from the calculate menu, in order to make sure that I've not made any errors. One thing you'll notice is that the underscore bar gets turned into an overbar here, and the underscore max and underscore min are turned into subscripts. Also, the Greek letter sigma is turned into the Greek symbol for that letter. So now I need a function to carry out the calculation of the probability, and I'm going to go select function information from the options menu and immediately narrow down the list to statistics, and this probability function looks promising, so I'll select the function information to read about it. And once I understand how the function works, I'll go back and manipulate the edit box so that it's called correctly for our situation. So the first two arguments are the lower and upper bounds of the range, so D min and D max, and the last two are the average and standard deviation. Now I can hit paste and then solve, and what I find is that there's an 81.9% chance that the next shaft will lie in the specified range. So the function information dialog provides other information for the rich set of functions that are specific to things like thermodynamic properties, which we'll discuss in section 4, heat transfer calculations in section 12, mechanical design, thermal system components like turbines and heat exchangers, which we'll discuss in section 21. Section 3 discusses how you can write your own functions or procedures, and then section 11 of these tutorials shows you how you can organize them into library files so that they would also appear in this window so that you can access them very easily. A very powerful feature of these is that functions and procedures can be written in any compiled language, so like Pascal or C or Fortran, and then these code segments, which are referred to as external functions and procedures, can be used in exactly the same manner as internal built-in ease functions and procedures. They can be coded so that units can be checked, just like internal functions, and warning and error messages can be returned. So this is one of a series of tutorials that's meant to describe the operation of the ease software. If you want to get more information about ease, or obtain the software, or access more of these tutorials, please go to fchart.com. These tutorials are excerpted from the book Mastering Ease, and Mastering Ease can also be obtained from the FChart website.